Hello everyone, welcome to Data Analysis with SQL. Today we shall explore the narrative COVID-19 tells through PostgreSQL. This has been expertly analyzed by your data analyst Georgia Gitau for actionable insights and understanding. Let us dive into the executive summary. Starting with a global perspective, the report delves into the dataset specifics, setting the stage for a detailed PostgreSQL guided exploration of COVID-19's impacts, and finishes off with a summary on the insights. The COVID-19 challenge. The report addresses the multifaceted challenges posed by COVID-19, some of which are global health crisis, socioeconomic disruptions, social and education challenges. The purpose of this analysis is to track the spread, predict future trends, and evaluate interventions. Coronavirus data analysis goals. Some of the goals here are basic exploration. We shall identify the start and end dates of the data. Spatial analysis. We will investigate how the virus spread across different regions. Comparative analysis. We will find the countries with highest number of confirmed cases, lowest number of deaths, and countries with highest recovery cases. The coronavirus dataset. The dataset that we shall be using here has been provided by Mentorness. The focus. The data centers around confirmed cases, deaths, and recoveries. We see that some of the key columns here are location, the date column, and the outcomes, which are confirmed cases, deaths, and recovery cases. Let us dive into the data exploration. We shall start first off by importing the data into PostgreSQL. Obtain the COVID-19 dataset. In this case, it's the one that has been shared by Mentorness. Also, create a new PostgreSQL database to store the COVID-19 data. Once you create the database, you create a table in the database to hold the COVID-19 data with the following structure. Use the PostgreSQL import-export data feature to load the COVID-19 dataset into the coronavirus data. The coronavirus table shall be created in the format that has been displayed in the picture alongside this. In the second question, we need to check the null values. Now, we write a code to check null values. This step ensures completeness, affirming the reliability of the dataset for accurate analysis. From the query that has been run, it is seen that when the syntax is run, the output returned is empty. Therefore, we do not have any null values. Our second analysis question is to check the number of rows. Now here, we're going to use PostgreSQL's count function to establish the dataset scope. This is done by calculating the number of entries. The output returned from the query is a total of 78,386 entries. The fourth analysis question is to check what is the start date and what is the end date. Here, we shall use the min and max functions. The output returned shows the dates when the data was first captured and the last date of the same. The fifth analysis question is the number of months present in the dataset. We see that from the dataset, we have an availability of 17 months that are present, and the query that is displayed on the left side does the same. The sixth analysis question is to find monthly average for confirmed cases, death cases, and recovered cases. Now, this query calculates monthly averages for confirmed cases, death cases, and recoveries in the coronavirus dataset. It rounds off the results to whole numbers, and then the results are then sorted yearly and monthly. On our seventh analysis question, we are to find the most frequent value of confirmed cases, death cases, and recoveries. We know that the most frequent value is supposed to be the mode. In this output, we see that it presents the results for each month along with the corresponding mode values for confirmed cases, death cases, and recovered cases. The 8th analysis question targets on finding the minimum values for confirmed death and recoveries per year. Now, this query analyzes coronavirus data to find the yearly minimums for confirmed deaths and recoveries. It groups the data by year and then selects the minimum values for each category within each year. Finally, it sorts the results by year, and this is done using the order by function. Our 9th analysis question is to find the maximum values for confirmed death and recovered. Just as we said with the minimums, the maximum query is nearly the same, only that this time we're using the max function. Our 10th analysis question is to get the total number of cases of confirmed deaths and recovered each month. Now, this SQL query extracts the year and month from the date column in the coronavirus table, then groups the data by the extracted values. It calculates the total number of confirmed cases, deaths, and recoveries for each month and year, and finally orders the results by year and month. Our 11th analysis process is where we're going to check the coronavirus spread out within the confirmed cases. This SQL query calculates the following metrics. We're going to see the total number of cases, the average number of confirmed cases, the variance of confirmed cases, and the standard deviation. The results are rounded to the nearest integer for readability. The 12th analysis question is to check how coronavirus spread out with respect to cases per month. This SQL query extracts the year and month from the date column in the coronavirus table. It then calculates, just as previously, the total number of cases, average number of deaths, variance of deaths, and standard deviation of deaths. These results are rounded to the nearest integer and grouped by year and month, then ordered by year and month. Our 13th analysis question is to check the spread with respect to recovered cases. In this case, it shall be similar to the 12th question. However, the results are only rounded to the nearest integer. We shall not group and we shall not see the order by. Our 14th question is to find the country having the highest number of confirmed cases. Now, the SQL query that you can see here retrieves the count with the highest total number of confirmed cases from coronavirus table. It summarizes the confirmed cases for each country, grouping the results by country, ordering them in descending order based on total confirmed cases, and limiting the output to only the top country with the highest total confirmed cases. The 15th question, here we see that this SQL query retrieves the country with the lowest total deaths from coronavirus table by summing the deaths for each country, grouping the results by country. Here we're checking the lowest number of death cases. Our last analysis question is to find the top 5 countries having highest recovery cases. Our query here checks the top 5 countries, and it does so with the query that is shown in the image below. Alongside it sums the recovered cases for each country, groups the results by country, and finally it orders them in descending order based on the total recovered cases and limits the output to the top 5. Now, the insights and findings of this data analysis were several, and they've been listed in this. Future directions in COVID-19. We do have long-term effects that were experienced, and so one of the direction is focusing on potential organ damages and neurological complications. We also need to see variants and mutations that can be experienced with the coronavirus. Thirdly, we will improve our diagnostics to develop faster, cheaper, and more accessible diagnostic tools. Our 4th point is going to be universal vaccines, and our 5th point is on global preparedness. Thank you so much for your time and your attention. I believe that this data analysis has been impactful.